Now, this is a really interesting paper. There's two types of blue light hazard that I want to go over with you. One is the rhodopsin mediated, and then there's a lipofuscin mediated. Both of these are important, but this one I want to highlight because I know Chris spoke here. Chris wrote an excellent paper for Western A. Price. I don't remember how long ago it was, but he talked about vitamin A, its link to, in the eye, to opsins and also to obesity. This is the path where it goes. When blue light comes in, what happens? Retinal separates from the receptor, the opsin protein, then has to be recycled. What happens when there's too much high energy blue? It cannot recycle fast enough, so vitamin A drops. That's why vitamin A is always linked, not causal, but it's always linked in some way, a correlative link to obesity and most mitochondrial diseases. That's the key. And that's the take home that I want you guys to understand. And the reason why blue is an issue, vitamin A is yellow in color. It's a complementary color. So what does that mean? That means that blue light in AM sunlight is incredibly important to your vitamin A cycle. That's the reason why it's important, because blue light's what makes vitamin A in your brain. Here's the action spectrum for the blue light hazard. You can see, starts at 400, but the peak is 435 to 465. That's why all my glasses block that. That's the reason why I think Dave is a great guy. The fact that 2 years in a row, he bought everybody the blue blocking glasses. The sad part is, looking out in this audience, not too many of you are wearing them.
They're all gone.
Okay. What's the key? Cones regenerate at night in darkness. AMD is now explosive. It's a blue light disease. Cataracts are also explosive. The rods regenerate in daytime. Believe it or not, most of the ophthalmologists didn't even know the stuff that was on this slide. The key is AM UVA light due to molecular resonance in terms of how it's made and how it works. And AM light, the key critical parts is UVA and infrared A light to regenerate the photoreceptors. Everybody knows that UVB makes vitamin D. Not too many people know about the effect of UVA and nitric oxide, both in the mitochondria and actually on your skin. It's important. This also reduces blood pressure, okay? Visible light is mostly eye camera function. That's what most people focus in on, and that's why we know a lot about it. But here's the big one. What's the photoreceptor regeneration? I told you from that retinal picture before that it's really far apart. How does this happen? Well, I told you that red light penetrates deep into the fat layer where the arterioles are. So that means it gets down to where the arteries are. And this one is not important. This is the boson effect, the two loops that I told you about. But here's the crazy thing. When you look at this, light comes through the eye, you get the slowdown effect. You know that the retina is backwards. When you look at the retina in an anatomy book, here's the optic nerve, here's the back of the eyeball. Why did God or evolution, whoever you choose to believe in, build it like this? Because it needed light to slow down more, to do what it needs to do. And guess what? When we have these diseases, you know where retinal detachments occur? Between the photoreceptor here and the RPE. That's where the blood goes. And that's why you become blind. Because all these things atrophy. All the receptors, the photoreceptors atrophy because there's no UVA and no infrared A light. So think about that the next time you put your contacts in or your sunglasses. Again, back to this one. Melatonin is what regenerates every photoreceptor in your eye. And you only make it when you have UVA and infrared A light. There's the hole again. There's the OCT. You can see how thin the fovea is. The blood vessels are down here. How does it happen? There's the picture again. Take a look. This is a picture I showed you last year. This is a chloroplast. That's hemoglobin. This is photosynthesis. They're exactly the same. What's the difference? Iron's in the middle, magnesium. Anybody want to take a guess what the difference is on the periodic table between magnesium and iron? I'll save you. Electrons. 26, 12. You know why? Plants aren't complex. They're planted into the ground to the magnetic field. Their canopies in the sun. You're designed to move across the magnetic field. So you need more electrons. By whose law? Einstein's law. It's called the photoelectric effect. Light can only interact with electrons. When you're complex, you need an atom in the middle that can absorb more light. Guess why hemoglobin absorbs 250 to 600 and cuts off? That right there. Okay? That becomes extremely important right here in your eye. Light enhanced diffusion, infrared light, and this is what it's meant to be. There's the retinal vessel and there's the photoreceptor. When light hits the distance, and you saw the distance in that picture I show you is really big between the vessels and the fovea. What bridges the gap? Water. Water is the perfect red light chromophore. It absorbs all the way up to 300 nanometers. So what happens when the light comes on, when that AM sunlight comes on, it changes the density of water and makes a fluid wave go there. So there you got McKissick's work from this morning coming right to you. That is a soliton type of sound wave that crashes in to the photoreceptor to help regenerate it. There's where light becomes a sound wave, what we call an electromechanical disruption. And it goes further. So what's the big difference? The velocity speed is what changes in the photoreceptors. The backward retina, told you before, it slows light down. You need the light to slow down. Everybody thinks the speed of light is constant. It is. By whose law, Josh, does that change? Isn't that Fermat's law, that it changes when the medium changes? See, we're not talking about the speed of light in space. Now we're talking about the speed of light in your tissues. It follows a guy's principle called Fermat's law. And Richard Feynman made that really important when he discussed quantum electrodynamic theory. I don't expect any of you to know it. But the reason why it's important, it's the reason why your retina is ass backwards. Again, the majority of sunlight that falls to Earth is infrared A. What did Ruben tell you why we got so interested in the quantlet of using photobiomodulation? You now know it's one of the ways that you can regenerate the photoreceptors of your eye. What if I told you that we could make the third eye in your radial artery by delivering infrared A light, because you know it penetrates right in, because I showed you a picture, didn't I? So if you're an idiot and keep using blue light, can you work around this in a certain way? The answer is you can. Turns out the retina is the key to getting energy into all the growth and metabolism pathways in your body. I know that most of you don't believe that. But I got a little bit more coming for you. We're back to the slide. Energy and mass, they're both the same. The only thing that's different is the environment they come in. This was a famous Paleo book, but take a look here. It all starts with light through the eye. This is the biggest false narrative on the planet, and 99.9% of people believe it. Now you know why I don't. Now, anytime you open a book, take a look what it says. Yes, circadian rhythms do actually affect everything. Take a look at that one. The eye is a metronome for the body. These are all published. Okay, take a look at that one. It's all there. See, 12 years ago, 5 years ago, 7 years ago, nobody believed it. Because they needed to have sites and research. You know why? Because a scientist relies on that. But you know what a quantum clinician relies on? That's why me and Ruben have become good friends. We're really curious. And we're observers of reality, meaning that we look very carefully. Observations are the first key step in any science project or experiment. So I come back to this one. You learned about this one last year, then you learned about this one. The mitochondria makes the C inside of you that also captures light. Okay, and the light that it captures, according to Pollack's work, UV, and IR. It covers the entire solar spectrum. That's why life is the key. And why I told you before that around every protein, you have a hydration shell. That hydration shell, the reason why zinc and copper are important in enzyme function is because when light hits it, it makes a redox pile. The redox pile makes those free electrons. Those electrons change the density of water. That's actually what makes the protein work. It's not the mineral. The mineral affects water, and water is what drives the process. If you don't believe me, there's studies out there that now show that water around the ATPase makes the ATPase 100% efficient in red light. Find me any other engine on this planet that can do that. And you know what they also found? When they remove the water from it, it's not efficient at all. So what's really important, folks? These are all things designed to make you realize things that you've missed. And just so you know, this happened 650 million years ago. We covered this last year. This happened at the Cambrian explosion when all complex life came. Guess what happens? Energy flow through plants and animals is through chloroplast and mitochondria that both came from a symbiotic bacteria. And we changed this bacteria. It only works with oxygen versus the other prokaryotes that are on the planet. But what does it absorb? This absorbs UV light all the way up to 650. This one is optimized for blue-green light. The reason why they're coupled is through this chemistry, photochemistry. And this is the key. Your future is totally tied. This is Doug Wallace 101. When you become a mitochondriac, you realize your sixth sense is your mitochondria. It pays attention to every electromagnetic wave that's present in your environment, and it makes the adjustments. You heard from Ruben and some of the other speakers about Fritz Pop. Every cell in your body at night is designed to release extreme low-frequency UV light. It's no longer conjecture, it's now been proven. So don't you think that would be important when melatonin gets released at night? What did I tell you about UV light and melatonin? Yeah, we can do some pretty amazing things when you look into it. There's the proof. It's out there. Roeland Van Wjck's book, what Ruben showed you, that's another book that was on my banner earlier. Low dopamine. And here's the key. We're getting very close to the end. I said to you in the beginning, do you believe that obesity could be caused in the eye? And I told you in the beginning that most of you wouldn't believe me till I got close to the end. Well, what happens when you have a low dopamine state, the choroid in the back where the RPE is, the first thing that happens when it loses light energy, it gets thicker. I want you to notice what that says. 2017, the first change that occurs in childhood obesity is thickening of the choroid plexus in the human retina. So how freaking crazy am I now? Tell me.